Good afternoon, everyone. I'm Bill Squadron, President of Our Energy Policy, and welcome to our webinar today on biofuels, agriculture, and energy, an important topic that really affects our energy transition and all the issues associated with state and federal energy policy. We have a terrific panel here to discuss these issues. We're going to dive into it in just a minute. One thing I do want to remind everyone is that toward the end of the hour, we will open it up to questions from the audience. So if you do have questions, please type them in and we will get to as many of the questions as we possibly can. So use the question icon to submit any questions that you have. I also want to let everyone know about our Energy Library, the program that you can find on the Our Energy Policy website that has all kinds of materials, papers, reports, studies, and so forth on this and every other topic, but particularly with respect to this topic, we are going to be highlighting some recent materials that will back up and provide additional information regarding the topic that our speakers will be addressing. Finally, very important for us to thank our partners. We have a wide range of partners that support the work of our energy policy. As you all know, we're a nonpartisan organization that's devoted to facilitating civil substantive dialogue on the critical issues and working with our policymakers to convey that so that they can benefit from the input from experts around the country and from all of you. So thanks to all of our partners, as you can see here, and thanks particularly to our co-host today, the firm of ArentFox Schiff. And I'm now going to introduce our moderator, Karen Carr, who is a partner at ArentFox Schiff. She is one of the leading experts in the country on the law involving agriculture, food, environment, biotechnology. She's a co-leader of the ArentFox Schiff AgTech group, and we're very pleased that she's going to be moderating the discussion today. So Karen, I'm now going to turn it over to you.
Thanks so much, Bill, and thanks to everyone for joining today. Really looking forward to this conversation with so many excellent experts. So with that, I will start with introductions of our expert panelists. First, we have Dr. Dilpreet Bajwa. Dr. Bajwa is professor in the Department of Mechanical and Industrial Engineering at Montana State University in Bozeman, Montana. He received his PhD in 2000 from the University of Illinois, Urbana-Champaign, and he worked in various research and development leadership roles in the wood products industry. His current research is focused on the development of multifunctional materials from nanocellulosic feedstocks and fiber polymer composites. We next are happy to be joined by Dr. Reyhaneh Shenassa. Dr. Shenassa joined the Bioenergy Technologies Office in the Office of Energy Efficiency and Renewable Energy at the United States Department of Energy, and she joined in March of 2021, serving as the chief engineer. In her role, Dr. Shenassa is working to address key challenges to the integration and scale up of bioenergy technologies. Before her government service, Dr. Shenassa worked with Valmet, a global developer and supplier of process technologies, automation services for the pulp, paper, and energy industries, and she served in various research and development roles for Valmet. She obtained her Bachelor of Applied Science in Chemical Engineering from Sharif University of Technology in Tehran, Iran, and her Master of Applied Science and PhD in Chemical Engineering from the University of Toronto in Canada. Next, we have Joanne Ivancic. Joanne is the co-founder and executive director of Advanced Biofuels USA, which is a nonprofit educational organization advocating for the understanding, development, and use of sustainable renewable fuels in the United States and around the world as an immediate carbon reduction solution. Under her direction, Advanced Biofuels USA maintains an online library of more than 45,000 indexed articles related to renewable fuels and produces 3 monthly newsletters. She's been observing the development of advanced biofuels research and financing for more than 20 years and has been voted one of the top 100 people in bioenergy by Biofuels Digest readers and editors. And then finally, we have Troy Bredenkamp, who since January of 2021 has served as the Renewable Fuels Association's Senior Vice President for Government and Public Affairs. Previously, Mr. Bredenkamp served as the Executive Director of Renewable Fuels Nebraska, the trade association for Nebraska's ethanol producers. And before that, Mr. Bredenkamp served as the General Manager of the Nebraska Rural Electrical Association, Executive Vice President of the Colorado Farm Bureau, and Director of Congressional Relations for the American Farm Bureau Federation here in Washington, D.C. So as you can tell, we have a really super lineup of folks today from whom we can learn an awful lot about the intersection of agriculture and energy, with biofuels being right there at that intersection. So to go ahead and kick us off, I'll start off by asking an overview question. We have lots of veteran studiers of biofuels on the call today, but just for the folks who may not be as familiar with these issues, and I'll just ask folks to keep it at a 50,000 foot level, if a couple of you would please provide an overview of the biofuels landscape. And for this one, I'll start with Dr. Shenassa.
Hello, thank you so much for having me and giving me this opportunity to address this very wonderful audience. Biofuel is bioenergy which can be produced from biomass and consists of non-fossil and biodegradable organic material. And there are four major categories of biofuel: ethanol, biodiesel, green diesel, and a fourth group that we call others, which sustainable aviation fuel is part of that. Ethanol accounted for the largest share of US biofuel production in 2021, 85% of production and 82% of consumption was ethanol. In the United States, it's mostly made from cellulosic, from cornstarch, but we at the Department of Energy at BTO, we are hoping to, we are collaborating with the industry to have technologies that are using cellulosic material to make ethanol. Another category is biodiesel. Is a renewable biodegradable fuel manufactured domestically from vegetable oil, animal fats, or recycled restaurant grease. This is made from trans esterification, and it has a byproduct which is glycerin, like 10% of that, and the rest biodiesel. It is usually blended with petroleum diesel for consumption and accounts for the second largest share of US biofuel. 11% produced and 12% consumed from the total biofuel in 2021. So ethanol and biodiesel are the most common type, but they are both first generation biofuel. And we are hoping to develop next generation biofuel. We are working with the industry towards that. We can use waste, cellulosic biomass, algae, and for example, and to make hydrocarbon biofuels. These are drop fuel biofuels that can serve as petroleum substitutes in existing refineries, tanks, pumps, vehicles, smaller engines. In these categories, I can mention two examples. Renewable diesel is a drop-in fuel, is a fuel chemically similar to petroleum diesel, and it's produced most often by hydrotreating of fats, vegetable, and oil and wood waste cooking oil, but also can be produced from other biochemical and thermochemical technologies. It made 3% of the biofuel production and 5% consumption in 2021. And the last one that I'm going to mention is other biofuel, as I said, is sustainable aviation fuel. And these renewable hydrocarbon, again, drop-in, can replace petroleum-based fuel existing using the existing infrastructure. And generally, we are hoping that these biofuels are used in hard to electrify transportation sectors, such as aviation, marine, and rail.
Thank you so much, Dr. Shenassa. Joanne, do you have anything to add to that helpful overview?
Yeah, that was pretty comprehensive. I would say also to remember that there's other renewable fuels like renewable natural gas and renewable DME, bio compressed natural gas and things like that, and fuels that are being used in marine, marine maritime shipping kinds of things. And on feedstocks, since I'm the advanced biofuels person here, I want to really emphasize the efforts to use agricultural waste, forestry waste, and things like that. Praj in India is one of the leaders, and there's a biorefinery in Romania that is using wheat straw. So things like wheat straw, rice straw, things like that, to also our feedstocks, and that we will be using more of, I hope, in the future.
And Troy, I know you're coming at this from an agriculture perspective. Anything else to add to the landscape here?
Yeah, I think I would just add, when you talk about agriculture, everyone talks about value-added agriculture. There's probably not a better example of value-added agriculture than what starch-based ethanol has done for agriculture from an economic development perspective. It's taken an industry that in 2002 had 60 or so biorefineries producing about 3 billion gallons to the point in 2022 having over just right at 200 biorefineries producing almost 18 billion gallons of starch-based ethanol. And keep in mind, that's not the only product that comes out of the corn kernel. You also have distillers grains that goes into feed and livestock, and then you have corn oil that is being used for not only biodiesel but also renewable diesel. So it really is just a tremendous industry that has just blossomed within the last 20 years. That's first generation renewables, but we expect it to do a lot more in the future.
Great. And go ahead, Joanne.
Let me add one more thing on the soy that Troy reminded me about with biodiesel or with using soybeans. One of the reasons that the oil was available is because you really need to take it out of the soy to make the soy meal. That's the main product that we grow soybeans for is for animal feed. And to make that digestible, you take the oil out. So basically it's not a waste, but a co-product. And I think that's an important thing to understand about this. That there's multiple things coming out of these feedstocks.
Yes, go ahead, Dr. Bajwa.
Thank you very much, Karen. I think previous speakers have added a lot about the biofuels, but the one category I want to add to this also is solid biofuels. And the solid biofuels have a big share in the market as well, starting with wood pellets, charcoal, wood chips, firewood, and then on the gaseous biofuels, syngas and biogas are two another important products that serve under the sustainable biofuels too.
So pretty incredible landscape for these kinds of products. So just want to transition now from sort of the overview to understanding from you all your views about the key use cases for these products. And I'll ask about it in two different ways. One, what are the current use cases? And then what are those that you see that are expected to emerge coming down the pipeline, no pun intended. And for this one, we'll start with Dr. Shenassa.
Thank you. I always talk about biofuel and liquid biofuel mostly, and the transportation sector. That's where I work. I work for the transportation sector of the ERE at Department of Energy, and most of the time I focus on that. Transportation accounts for 34% of US greenhouse gas emission, and we in the US have the potential of making 1 million ton or in excess of that biomass annually that can meet the needs of hard to electrify transportation modes. Aviation, marine, and rail. For example, it's estimated that 645 million tons of biomass is needed to make all the sustainable aviation fuel needs in 2050, which is projected to be 35 billion. So the biggest market pool currently is sustainable aviation fuel. At this time, DOE has two large-scale SAF demo projects, Fulcrum and LanzaTech. And sustainable aviation fuel, the use of the biofuel can be used to power aircraft, and it has similar properties to conventional jet fuel, but with a smaller carbon footprint, and the greenhouse gas emission can dramatically be lower than the conventional jet fuel. Another use of biofuel is drop-in sustainable marine fuel. At this time, we have renewable diesel, biodiesel, hydrotreated vegetable oil, bio-oil, and bio-crude that can be used in the marine engines without major modification. But there are some emerging marine fuels which the marine industry is pursuing with the potential for zero or near zero greenhouse gas emissions. Those include biomethanol, lignin alcohol mixes, and bio-based natural gases. These emerging marine fuels offer flexibility and self-performance advantages, but may require new engine designs and other mechanical modifications, so it's not as close in the future. And another use of biofuel is in rail. Rail fuels, renewable diesel or biodiesel are used in rail fuels. These are some examples that I wanted to mention.
Terrific. And Joanne?
Yeah, I would say, and maybe Troy would elaborate on this, one of the uses of ethanol is that it replaces MTBE and carcinogenic things that we use to get octane to stop NOx in engines. So it's not just a carbon reduction thing, but also that, and it replaces toxic chemicals like butane. So the more ethanol we use, the less harmful chemicals we can, or the more harmful chemicals we can avoid. And the other uses that are not just in the US, but in other parts of the world is using it for cooking oil, using renewable fuels for cooking oil and for heating. And I think that is something to think about when we talk about cooking oil in or cooking fuel in places where you use dung or wood in enclosed areas, the terrible health effects of that. And so renewable fuels is something that we use for those too. So I just want to make sure those are also kept in mind.
Dr. Bajwa, did you have something to add?
I just wanted to add what Joanne was telling. I think that another big application for biofuel is in power and energy generation. In a lot of the Southeast Asian countries, I'm seeing more and more agricultural feedstock are going into power generation. So that is a emerging area where there is a lot of feedstock and they want to utilize, because energy is very expensive over there, just being short of some of the bio resources like we have in Northern America, a lot of wood and a lot of cellulosic feedstocks. And so they are trying to tap a lot of agricultural biomass. I know for rice, wheat straw, that is going into the power generation as well. And what Shenassa was telling, and I can say that Title 10/29/11 dictates Department of Defense to use no less than 25% of total energy from bioenergy sources by 2025. So they have been really pushing hard to use biofuels. The most largest consumer, US Army, is of biodiesel. It is approved for non-tactical military vehicles, but it is not approved for tactical vehicles, including tank, amphibious vehicles, and military vehicles. So they are really pushing hard to use these biofuels into the military. So that will be also a major demand for biofuels from US Army or military.
Joanne?
Yeah, to add to that, there is a federal rule regulation that does require vehicles owned by the federal government to be fueled with renewable fuels as much as possible if they're like within a certain amount. And here I live in Frederick, Maryland, and I'm sure that the one E85 station that was put here, W Express, was put here because we have Fort Detrick, and there was going to be a market for that fuel because they're so close to a federal installation.
Great. Thanks, everyone. So moving now from sort of use cases to more of a landscape question across our economy. Troy, can you talk to us a little bit about the role of biofuels in promoting U.S. energy security and or energy independence, and how biofuels can play a role in those two concepts?
Yeah, most certainly. I think it's important to note and to remind everyone that back in 2005, when the energy bill was passed and it included the first renewable fuel standard, one of the basic tenets of the passage of that was based on energy independence, national security. If you remember, back in 2005, we were dealing with an issue in the Middle East and a political and a military conflict. And so we wanted to lower our dependence upon foreign sources for our energy needs. And so the renewable fuel standard came about, and the result of that was what we've seen with this rapid growth within the starch, ethanol, and biodiesel worlds. Just to put it in perspective, we are now in 2022, ethanol in particular held up about 10.4% of the entire fuel mix, light duty, medium duty vehicle mix. And that's exactly what it was designed to do, to stretch the oil supply with a renewable product. And by the way, that amount of ethanol we are using today removes about 600 million barrels of oil needed from foreign sources. So it is doing its job. It could do a lot more. We are ready to do a lot more if the marketplace and if the regulatory climate was in a way that would indicate there's a growth pattern needed. We're certainly ready to take that on.
Perfect. Anyone else on energy on that topic? Okay. So I'm going to move now to a question that sort of puts what Troy was just talking about, sort of the flip side of the coin. So if we are increasing production as where demand is increasing, production is increasing, how do those production costs, how do we keep those low so that at the same time we're not sacrificing agricultural output for food production, which just as Troy was talking about was some of the geopolitical questions that come up with respect to sources of fuel. Also, we're seeing now questions about food production and the need for food security as well. So if I could invite Dr. Shenassa to talk to us a little bit about production costs, lowering production costs so that we've got good agricultural output for food production.
What I am going to address here is, in parallel to food production, what we can do to decrease the whole price and decrease the greenhouse gas emission, which also would help with the price of food. About 42% of greenhouse gas emission of biofuel from farm to wheel is contributed to the feedstock production. That includes production of fertilizer, and that is used in farming, and it's before feedstock is transported, converted, and then fuel is transported and used. So it's just the agricultural part of it. And so decarbonizing transportation and decarbonizing the agriculture are inherently linked. And by agricultural activities, we can both, basically these activities can serve as both sources and sink for greenhouse gases. And if we develop tools and strategies to quantify and improve soil carbon sequestration and ecosystems, we can produce biofuels with a lower carbon intensity. And this can lead to clearer water, less fertilization, runoff, and lowered methane emission. And if in our agricultural practices, we focus on maximizing soil CO2 sequestration, develop climate smart agricultural practices, produce clean energy on site from animal waste, and develop wastewater treatment strategies that can produce bioenergy feedstocks, we are basically producing biofuel, but making products that would bring the whole cost down in the whole system. And these producing marketable fuel and chemicals would incentivize these practices. So it is like a whole synergy between all of these.
Joanne?
Yeah, you mentioned LanzaTech before, and I think an important thing to know about them is that they use a biological process to convert industrial waste gases to fuels. So we have alternatives also to agriculture, and I'm working on some of them. And then thinking of, I'm here in Maryland, where our governor is just signing a medical marijuana, or a recreational marijuana bill. And so when you think of the biomass for some of these crops that are coming up, that's going to be available. So you only use the buds, right, for CBD or for medical marijuana or for recreational, and you have all these plants left. So really getting some more research money, getting some more attention to using agricultural residues to be able to make fuels. I think that will go a long way in addressing the question that you raised about how do we make our agriculture more efficient. To be looking at those things, to be looking at cover crops. They're developing something called pennycress, so that you can use cover crops that will also be able to make a feedstock for fuel. But then you get into the policies, because then can you get crop insurance for those? If you're making money on an agricultural waste, is that going to screw up how your subsidies for your agricultural subsidies work? And that we've run into that with the trying to use the pulp that's left over from sugar beets for making sugar. You've got lots of pulp left over, and it ends up in landfills. To make, I think we have a long way and a lot of opportunity for making agriculture much more efficient, and when we use some more of the agricultural residues.
That's right.
I would just like to chime in as well. I think it's important to note that from a cornstarch-based ethanol perspective, we are actually producing this growth in cornstarch ethanol has been done utilizing and using actual less corn acres now than we did 15 years ago. So this is through farming advancements, clearly technological advancements when it comes to hybrid seeds. The efficiencies found within an ethanol plant itself have all contributed to this rapid growth. And we don't eat a lot of number 2 yellow corn in this country, but we're certainly able to utilize it not only as a renewable fuel, but then turn it into a very high value feed product for livestock, which we do eat. So to us, it's a pretty good circle of life, if you will, where food production does not have to be hindered or hurt through renewable fuel production, particularly from a corn plant.
Yes, Dr. Bajwa.
Karen, I think Troy, Shenassa, and Joanne covered from the agricultural growing these crops perspective, but I want to also add is technology, because technology has a major role in bringing the price down. So one thing would be developing atom efficient technologies. Basically what I'm saying is utilizing all components of the feedstock. So like for corn, ethanol is a big major product. But DDGS is a significant part of the biorefineries. So if we can find value-added applications, uses, or new products from DDGS, so that will also help these refineries. And then another one is intensifying process designs, reducing capital costs, and lowering facility operating costs. So that is another one. And utilizing existing structures, infrastructure. So if we can co-locate other processing facilities and reuse the equipment and facilities, that's another way, I think, for price reduction. Reducing feedstock costs, like Joanne said, pennycress, camelina. So a lot of this new emerging crops are feedstocks for the renewable fuels that can lower the cost. And then just with the technology, I can share something is that fossil energy ratio. So over the last 10 years, we have seen the ethanol, the gasoline energy ratio is 0.8. But now ethanol, with all the improvements, the energy ratio has changed from 2.5 to 4. And similarly for soy biodiesel, it has improved from 3.2 to 5.5. So we are making progress. And I think what Joanne and Troy Shenassa mentioned, these are all steps towards lowering the price of the biofuels.
So Dr. Bajwa, you touched a little bit on infrastructure. And so I want to turn now to that topic just for a second and ask as many of you as care to answer, do we have the infrastructure we need to support this growing industry? How close are we to having enough infrastructure? Do we have enough biorefineries? Do we have appropriate pipes and pipelines and pumps? Or are there components that we really need to prioritize in order to get the most out of this growth possible? And I'll start there with Joanne.
Yeah, I'd like to start out with a shout out to the oil refineries that are repurposing their oil refineries to make renewable fuels. So there's a way that we are using some existing, what could be stranded assets and making some beneficial use out of them. But we're going to definitely be building more. There's a lot of investment that's needed to be able to take us to transfer. Just think, what we're trying to do is to replace what we get from petroleum and natural gas, replace what we get from and not take any more carbon that is in deep storage, and recycle the carbon that's already on the land and on the ground and in the air. And so if we're going to need more things to do that. And there's going to be controversies. There's going to be permitting. Who wants this kind of stuff in their backyard? Some people do, and see it as an economic development, and other people are going to fight it. But it's clear that what we have now is not going to be enough. We need to use some of what we have, but also are going to be building new and different things. I think also in the wood products area, there's a number of projects being built in the Gulf Coast in Louisiana, Texas, Mississippi area of new biorefineries, making particularly jet fuel and renewable diesel out of wood products, out of forest waste, out of wood industry waste, sawdust and things like that. And then also a number of them are also planning to do carbon capture and storage. So the infrastructure and the really the technology developed to do that is something that, you know, people in the future, in the next even few years, are going to have some really interesting job opportunities.
I would just add on top of that, Karen, you know, from a corn ethanol perspective, this industry will react to market signals and certainly regulatory climate. So when that time is ready, we certainly see another growth pattern starting even on the cornstarch side. As we drop our carbon intensity, which we are year over year, more and more new uses are coming to the forefront and opportunities for even corn-based ethanol to participate. Keep in mind that from 2007 to 2012, so 2007 was the year that the renewable fuel standard was revised. From 2007 to 2012, in 5 short years, we doubled the amount of capacity within the industry. We could grow very rapidly if the market signals are there. Other infrastructure, obviously retail level, we want to see pumps that can handle higher blends. We support the USDA programs, HBIP, that allow us to do that. But here's probably the most critical piece of infrastructure people don't think about: the vehicle itself. We got to have OEMs start to make flex fuel vehicles again. The incentives for them to make flex fuel vehicles were taken away, I believe, in 2016, 2017. They've really stopped making FFVs. Meanwhile, we have people adding E85 pumps in California. So they're looking at it from a low carbon fuel perspective. The vehicles aren't necessarily being produced that can utilize that higher ethanol blends. We need at least a hardening of E25 to E30 for vehicles, but we'd love to see FFVs being made again. And that's something we need to work on here in Washington, D.C.
So Karen, I just wanted to add what Joanne and Troy said. I think from what I see that we need to modify existing facilities. Right now, we don't have capacity to send these blended fuels through the existing pipelines. There are several issues. There's the stress cracking, corrosion is water absorption. These fuels are hydrophilic. So I think, and also that the terminals don't have the capacity to store, because most of this fuel is now being shipped through trucking and rail cars. And so that is one thing. It needs a major investment to make this grow. We are lacking in the investment side.
Joanne.
Yeah, I think, but I also would be remiss not to mention the carbon pipelines that's been proposed in the Midwest. If we are going to, when you ferment something, you get a lot of carbon dioxide. You see it in beer, you see it in champagne, but you can capture that and store it. But if you don't have the right geological structure close to where you're making it, then you're going to need to ship it someplace where there is that, and getting that kind of infrastructure in. Also, if we're going to be using renewable hydrogen to make renewable fuels, to make the sustainable aviation fuels and the renewable diesel, we're going to need pipelines that can also transport hydrogen. And there are some, but are they going to the right places where we need them? So there are going to be things like that that are still required.
Dr. Shenassa.
I think that if we look at solid biomass, we have 100 or plus years of dealing with liquid and gases at feedstock, but we do not have that experience with solid, especially hard to process and convert solids, such as energy crops, agricultural residue. And what I think would be ideal is to have local conversion of these hard to process material to intermediates, and then further upgrading them in existing infrastructure in refineries. So once we come up with some of these optimum scenarios, then we can see what infrastructures are needed for that scenario.
So I'm going to ask a little bit of a lightning round question, because I think we have just a few minutes left before we turn our questions over to the audience. And that is about the economic prospects for biofuels and for the industry. Are you sort of on a stoplight chart, red, green, yellow? Where do you fall? And I'll just start with Joanne, and I'll make my way around the circle here.
I'm bright green. I think there's a lot of opportunity, and I think we really, really need to do this.
Dr. Bajwa.
I agree with Joanne. We are at the green light. Actually, the current geopolitical situation has created a thrust for the biofuels to come in. See, what we are seeing is happening in the Europe and rest of the world, I think is the right moment for us, whether it's industry or the government, to jump in and to catch this opportunity and grow this industry.
Troy.
I'm going to go neon green. We are high on where we think even starch-based ethanol can move. As we lower our carbon intensity, and keep in mind the industry is committed to a net zero ethanol production or even carbon negative by 2050. That's an exciting opportunity, and it's going to open a lot of doors for us from sustainable aviation fuel to hard to electrify areas, and also all the chemicals that we can make from a biorefining process. So sky's the limit. We're pretty excited about our future.
And Dr. Shenassa.
In my opinion, we should not compare the price of biofuel with fossil fuel directly. The most commercial biofuel, that is HEFA, is at least 2 times the price of fossil fuel. And if we go to power to liquid, which is in future is maybe 10 times now. But what we have to see is that these products are not equivalent to the fossil fuel. They are better products. They do not add to the greenhouse gas emissions. They have sometimes additional benefits. So I think that when we look at the price or we look at the cost, we should see what is the cost of not doing that and look at it that way.
Mm-hmm.
Dr. Shenassa, can we put you down as a green light also?
Absolutely.
Great. So we've got unanimity as we among our panelists as we go into questions from the audience.
Great, thank you all. This has been a great discussion. This is Liza with Our Energy Policy, and we have a variety of questions from the audience. These are going to be directed to the whole panel, so whoever feels ready to answer, you can jump in. So the first one is, does the term renewable natural gas encompass only landfill biogas and agricultural livestock waste as the major sources, or are there any other large sources of biogas?
Who would like to take that one? Joanne.
Yeah, I'll say there's also work being done with wastewater treatment and using maybe and using the organic part of what you're doing with wastewater treatment and making biogas out of that too. There might be some other ones, but I can't think of them right off the top of my head.
Dr. Shenassa.
Any process does not make just one product, makes multiple products. For example, let's look at pyrolysis or catalytic pyrolysis. They make also a gas that is not condensable. So that is called, you can call it biogas. So currently what they do is that they burn that gas in order to produce the heat required for the process. But there may be better if we achieve good integration of the processes and the waste heat other places. These biogas can be used, for example, for hydrogen production. So there is another resource of the gas coming from the processes that we already are advocating for.
Great, thank you both. Our next question is, should developers be concerned about Treasury guidance that might implement export restrictions for biofuels that qualify for IRA credits?
Do you have any, Dr. Shenassa?
If we look at sustainable aviation fuel, that is a global biofuel because airplanes have to fill up their tank where they land. And for that, the global regulation comes from CORSIA, which tells us how much is the carbon intensity of this fuel. So if we want to export sustainable aviation fuel, for example, that should be used in Europe, it has to be, or even if it is used in the United States, I think it has to go with that description of carbon intensity in order to be considered sustainable.
Troy.
I would just add that when you're talking sustainable aviation fuel in particular, it's going to be critical to get the modeling right. We are very much advocates of Argonne GREET. Dr. Shenassa's Department of Energy gets it right. Corsia does not get it right. Their model needs to be updated. So that's an area that I think from a policy perspective, we're going to spend some time on, because it's important to have the best model available to give the best credits and the most accurate credits. We think that at this point in time is Argonne GREET, and we will fight to the end to make sure that that's included within the IRA provisions.
Dr. Bajwa.
Yeah, I want to add what Shenassa just said. So the biggest commitment for biofuels just happened at the World Economic Forum, Clean Skies. So there was back in September 2021, when 60 companies committed to use biofuels by 10% by 2030. And the One World Alliance, so that represents the airlines from Europe and US. So they are all into this. So they are planning to purchase, although a small number, 200 million gallons of ethanol-based sustainable aviation fuel in the next 5 years. So that's a positive step moving forward.
Great, thank you all. So the EPA announced an E15 fuel waiver last week. Can you speak a little bit about this waiver and if there's any potential for making that permanent?
Oh, I would like nothing more than to make it permanent. We certainly appreciate the Biden administration granting our request to have a waiver for E15. You know, E15 has all the environmental benefits that ethanol provides, except obviously 50% more per gallon. So we're excited about having this waiver over the summer. There is a challenge in order to get the permanent waiver solution fixed. That's going to take congressional action, literally an act of Congress. We're working on that, and we hope to have that before the 2024 summer driving season.
Perfect. Any other comments on that newly released waiver?
All right, I'll continue on. You spoke a bit about biofuels infrastructure, but can you talk about some of the key policy levers that would help grow that supportive infrastructure, and particularly at the state level?
Joanne.
Well, the big one is the groups that follow the California Low Carbon Fuel Standard, and Oregon has adopted a version of that. So has Washington State. A number of other states are looking at that, and so that really does get low carbon fuel into your marketplace in your state. Illinois has passed a tax credit, I think, for sustainable aviation fuel. So that is going to spur development of sustainable aviation fuel biorefineries in Illinois. And so there are definitely things that states absolutely can do. Minnesota for a long time has been a leader in requiring high levels of biodiesel in the fuel that's sold there, and I think Iowa is now passed for and a couple other states talking about E15 as having that be a required fuel to be offered by most of the fuel stations, gas stations.
Karen, I also want to add what Joanne said. I think the states also have to do something, either direct or indirect support to grow the feedstocks, the raw materials. So that will also help the biorefineries or the biofuel producers. That's another way. And hopefully either through local tax exemptions or the incentives for long-term loans that would be from states they can support.
There are several out here in Washington, D.C. exploring what a national low carbon fuel standard would look like. But Joanne was correct. The state level low carbon fuel standards that are out there and those states that are exploring those options, that's what's going to drive infrastructure within those regions or within those states, and certainly drive technology if they were to adopt a reasonable and prudent low carbon fuel standard for their state, like California, like Oregon, like Oregon.
Great, thank you. Can you just discuss a little bit your views on the use of renewable natural gas for heating buildings?
I'm sorry, I didn't hear the question.
Oh, yeah, no problem. The question is, can you discuss your views on the using renewable natural gas for heating buildings, urban environments?
If I may try that.
Yes.
One thing, if we are talking about renewable natural gas replacing fossil natural gas and from the origin of manure or dairy farm waste, I have had a project with Argonne and NREL National Lab, and they were doing calculation for us how to decrease the corn ethanol carbon intensity and what is that we can decrease, what is the measure, and what is the cost of that measure, one by one. And changing natural gas to renewable natural gas for the heat that is necessary for that, for in the corn process was one of the most efficient one. So it was not increasing the price much, 20-30%, but it was decreasing the carbon intensity hugely. But there is a caveat. Renewable natural gas is not that much available. It's not as available as we want it to be. So now thinking about producing renewable natural gas and using it where heating for cities are needed, it has a lot of infrastructure issues. But if that becomes possible, I think everybody would jump on the opportunity. Basically, is one of the ways to decrease this carbon intensity of a process if it can be replaced fossil fuel.
All right, thank you. Can you speak to the potential for biohydrogen? Is that something that is potentially commercializable?
Joanne?
I can't. I think yes. I don't have numbers, but I know that there's more and more. I'm reading more and more about investment into making biohydrogen. Basically taking the biogas from anaerobic digestion or landfill waste and taking the hydrogen out of that, and then you also will have other chemicals that you also get as you're doing that separation, and maybe the hydrogen and then your CO2 that you might also then sequester. So I think that it's I understand that it's less expensive to do than hydrogen from electrolysis that uses less energy. But the question again is what's the value of that hydrogen, and how are you going to use it? And but I absolutely think that that's going to be one way to get hydrogen. That's going to be a very important way to get hydrogen. But as Reyhaneh said, there is not that much. There's not enough, and we've got a long way to go to really be able to use all of the feedstocks and the opportunities that are available to make that. as effectively as we can. And then maybe then the question is, do you make hydrogen out of that, or do you drive cars and make renewable natural gas out of it? Do you use it for industrial and residential heating? There's so many demands to that. I'm sure it's going to have a market.
I would agree with Joanne. I think hydrogen is going to be an emerging market for a while. There's a lot of things that makes it make sense, and then keep in mind that the ethanol molecule has 6 hydrogens attached to it, so it could be a hydrogen donor in a hydrogen realm, or kind of a regiment. So all kinds of opportunities for hydrogen.
All right. What are the energy and emissions requirements for the process of converting feedstocks into usable biofuels?
This is a huge, sorry, I'm not even near this question because it is such a general question. It's so case by case. Sorry.
I'll take a stab at it.
Joanne.
You've got your fermentation. We've talked about that. Then you've got like hydrothermal liquefaction that can get you to biofuels. You can get all different kinds of enzymatic hydrolysis kinds of processes. So you have gasification, you've got pyrolysis. There's just many different technologies to get from your feedstock to either an intermediate or to your final product. And come to our website and go to the tag conversion technologies and go find a whole bunch of those.
Well, and keep in mind the Argonne Greek model accounts for almost all of it. So you can plug different variations into your production methodology into the Argonne Greek model, and it will model what your carbon intensity is coming out. From an ethanol perspective, we have to track everything from the corn production and the time that the corn goes in the furrow, or even before that, if they put fertilizer on, all the way until that ethanol product gets to a gas tank for the retail user. All of that is accounted for within our carbon score. So it's involved, it's complex, but it's also modelable through Argonne Greek, and ethanol does a really good job.
And that number is changing with the technologies. So that you improve your technologies in a plant, you make more efficient, the whole number changes again. So there's not a one number that you can say that it will work. So it is always varying.
Fantastic. I think our last question is, investor-owned utilities often push back on biofuels, saying that the industry and storage infrastructure are not at utility scale and therefore not reliable. How can we get past this obstacle to make these fuels more viable?
I will start, and then others can join. I can tell you just from experience, we've been talking to utilities about the use of biofuels as a backup generation source, as a mobile charging station resource. The lower the carbon intensity is for a biofuel, the more attractive it is becoming to utilities as a backup generation opportunity for wind, solar, and other things. So it's happening slowly, but I think as the carbon intensity issue becomes more important to the utility, then I think that's going to open avenues for biofuel to play a greater and greater role, maybe jumping out of a gas tank and into electric generation more and more, either as a backup source and things like that.
Yeah, I think you'll also think about fuel cells and ethanol as a fuel cells or and I know that there are a number of large companies that are using renewable diesel as their backup generator fuel.
I want to just add another thing. If there is a clear policy on the carbon credits, that may also incentivize some of the power companies to get to tap into biofuels too.
Well, everyone, I hate to jump in here because this conversation has been so stimulating. I want to thank all of you for your expertise and insights that you've shared with us today. It's very clear that this entire area of biofuels has enormous potential beyond what's being done today, and that technology is likely to play a significant role. So thanks for sharing all of that. I'd like to remind everyone that we have additional materials in the OurEnergy library on the OEP website, and encourage you to go there to supplement all of the great discussion that we've just heard. I want to thank all of our panelists. Thank you for taking the time and sharing your thoughts with us today, and thank Karen Carr and ArentFox Schiff, our co-host, for moderating the panel and for supporting OEP. Thank all of our partners for that. And to all of you in the audience, thank you for taking your time to join us today. Please be on the lookout for our next webinars coming up shortly. And we wish all of you a great day and good rest of the week, and look forward to seeing you again soon. Thanks to everyone.